This is our second tutorial on domain and range discrete, and this is going to be the ones with graphs. Now we looked at the tables, the mapping, and the coordinate pairs, and graphs works the same way in that our domain values are still our x values, and our range values are our y values. And while the tables and the mappings look very similar and work the same, the coordinate pairs end up looking similar to the graphs when we write down our final answers. So I'm going to keep the coordinate pair example up here so that we can look at it. In order to get our domain and range values from the graph, we actually need to get the coordinate pairs that represent those points. So we're going to need to make a list of coordinate pairs, just like the one that you already see on the screen. So this has an extra step of getting the values first and then figuring out the domain and the range. But we still have to know the x values, and the x is our horizontal axis. So I'm going to label it here. And our y is still our vertical axis, so I'm going to label it there. And when we get our coordinate pairs, it's important to remember that the first number in the coordinate pair is the x. That's the side-to-side numbers, the left and the right. The second number in the set of coordinate pairs is the y. That's the up and the down numbers, the vertical numbers. So I'm going to do this for each pair. I'm going to get each set. And I'm going to start over here with this one down here low. I'm going to get it set. I'm actually going to do my counting and my labeling in red, just so that it looks a little bit different. And we always start counting from the origin, which I'm marking right here. The origin is our 0 spot. 0 on the x, 0 on the y. Okay, and that's where we start our count from. So from here, I need to know that x move, how far left and right does it go? So that's what I'm going to be figuring out first. So from the origin, I have to go to the left, 1, 2, 3, 4. So my side to side, I went sideways 4, but since it was left, that's going to be a negative because that's the negative side of the x-axis. From there, I'm still not on the dot or the point, so I need to go down to get to it. Down 1, 2. The up and the down move is my y, and I had to go 2. And since it was down, that 2 is also a negative. So that spot is the coordinate -4, -2. Now I'm going to do it with this next one over here. And again, I'm going to do my counting in red. From the origin, I have to go left 1. So my sideways number is 1. But since it was left, it was negative. And then I have to go up 1, 2, 3. So my up and down number is 3. Since it's up, it's positive. Now from there, I'm just going to drop down low here and look at this one. This one down here from the origin goes to the right one. So my sideways move was 1, and since it was to the right, it's going to be positive. But then to get to the dot, I have to go down 1, 2, 3. And remember, the up and the down move is the second number. And since it was down, I need to include a negative. Now I'm going to go over here to this dot, or this point. Okay, and again, from the origin, I'm going to go over 1, 2, 3. So my sideways movement was 3. Since it was to the right, it's positive. But notice I don't move up or down because I'm already on the dot. So if I don't need to move to get to that spot, then my second number needs to be a 0 to show that I don't move. And that brings in a similarity with this one that I sort of skipped here. Now we're going to look at it because it is similar to that one, but it works a little different. Starting from the origin, I don't actually move left or right. I just stay there. So since I can't move left or right, it lines up with the origin, and that origin number is a 0. So the 0 this time is on the x. But I do need to move up 1. So my up and down numbers are 1, and since it was up, it's a positive 1. And now I'm going to do this last dot up here. From the origin, it's to the right, 1, 2, 3, 4, 5. So my right 5, and again, since it's positive, it needs to be since it's to the right, it needs to be a positive. And then from here up, 1, 2, 3, 4, 5. And again, since it's positive, since it's up, it needs to be positive. And now I'm going to look at just making my list. Because I said, okay, we need to have a list of these. So I'm going to make my list of these numbers. -4, -2. And then I've got -1, 3. And then 0, 1. And then 1, -3. 3, 0. And 5, 5. And I'm going to make sure I've got them all because it starts to get a little bit busy and you got to make sure you've got all your coordinates. I'm going to count my points, my dots. So I've got 1, 2, 3, 4, 5, 6 dots, 6 points. So I need to have 1, 2, 3, 4, 5, 6 sets of ordered pairs, and I do, so I've got them all. Now I'm going to come down here and write my answers. And again, I'm going to highlight the domain numbers. And that's the first number in each pair because the domain is the X. So if I go back to doing that so that I always have those ready, and I'm going to label them. My domain values then are going to be -4, -1, 0, 1, 3, and 5. Now I just happened to accidentally get them in the right order if you wanted to go from low to high. But if they didn't come out in the right order, then you could rewrite them like we've done before. My range numbers are the second ones in each pair. So I'm going to label them. And I'm going to write out my range values. So -2, 3, 1, -3, 0, and 5. And these, once again, are not in order from low to high. So if I rewrite them in order, I would get -3, -2, 0, 1, 3, and 5. And again, these are the same. It's just this one's sometimes considered a better answer because it's in order.